Okay, so far we've been using normal distribution to find probability. So given mu and sigma, what is the probability that x is less than 75 or x is greater than or equal to 125 days and so on and so forth. But what if we want to use it in the inverse way, the backwards way? That is, you are given a probability 90% or 75% and you want the corresponding x for that probability. Okay, so we are going backwards now. So let's look at an example. The same example like before. Okay, random variable x is the time for completing the construction. Okay, total construction time. So mean is 100, standard deviation is 20, that we know. Okay, and the question is not about finding probability, but we're given a probability. Suppose we want to set a due date, okay, such that you will have 90% probability of meeting the due date. So in other words, what is the probability? Well, what is the x value such that the cumulative probability for that x is equal to 90%? In other words, it's something like this. We want to know what that x is so that you set the due date there. The probability that you will meet the due date or you will finish the construction within that date is 90%. And the formula for that is x equal to mu plus z sigma, where we have to find the corresponding z for that 90%. So for the standard normal distribution, okay, for 90%, what is the z? Yeah. And again, we can do this from the table, and I'm going to show you how to do the table because sometimes you have access only to the table, so you need to know how to use the table. But if you have Excel, then I would suggest that you use the Excel function for it. So let's look at how to do this in the table. So we want 90% probability. So now remember, probability is inside the table. Okay, the z values are on the margin. So now you need to look for 90%, and it's likely that you may not find the exact 90% here listed in the table. So you have to do some adjustment or some approximation. So here 90% is in between these two values, right? Now it looks like it is closer to that than that. Suppose if it is kind of in between, then you can find the z value for that and z value for that probability and average the two. So for example, the z value here is 1.28. So that's 8. 1.28. So that's 1.28 and 1.29. So we can average the two and then say 1.285. Okay. So that's what we will do. It's kind of in between. So it's not really very close. Suppose if it is very close to one of the two, then you can go with that one particular one. Like for example here, if you're looking for 87.9% probability, then this is it. Or 88% probability. Well, even then it's kind of in between. So you have to use your judgment a little bit here. So I'm going to take the average between 1.28 and 1.29 and use 1.285 as the z. Then x is mu plus z times sigma. Now Excel has two functions, like in the DIST distribution function for probability. We have for the inverse two functions. So one uses the probability, mu and sigma. So this will give you the x value directly. Or you can use the .s.inv function, which takes in only the probability. This will give you the z value only. So we have a cumulative probability of 90%, right? 90%. So we want the X for 90% cumulative, then go norm.inv. So then give probability and then mu and sigma. I'll absolute reference those. And so this one is more accurate. Remember, we had to do a little bit of averaging and stuff here in the table. So table is not very accurate, whereas Excel functions will be accurate. So if you want to use the norm.s.inv, so that will give you the z value for that probability, cumulative probability. See, it is 1.281. We used 1.285. So that's the reason why there is a discrepancy. So now we have to compute the X value ourselves. So we can copy this formula because we have absolute reference to mu and sigma. Okay, so you get the same answer as that.